took a couple of years for them to finally auction it all off.
There is a market for this old stuff. I guess anybody that goes to the Dayton Hamfest knows that there appears to be a market for just about everything. It sounds to me like not only...
when you set it to a given dial reading, what frequency it's putting out. So if you have a signal, say at 3 megacycles, and you have a frequency meter and you dial it to exactly the same frequency, as you know, you'll get a beat note between the two if you put them into a mixer. And so you dial the frequency meter so that it's at 0 beat with the unknown signal, and then you can read from the frequency meter dial, typically not the frequency directly, but use a calibration chart to look up the frequency that the VFO is tuned to. So it's a process that takes some effort. During World War II, there were two very common ones. One used by the Navy called the model LM, and one used by the Army called the model BC-221. And they were variable frequency oscillators that came with calibration books, where for a given frequency like 3885 kilocycles, you could look up that in the calibration book and then set the dial on the frequency meter to that frequency. Once you had calibrated the frequency meter itself, which requires beating against a crystal of known, a crystal is stable and produces a reproducible frequency. Frequency meters were first developed back in the 1920s, and the first ones, the later ones were called heterodyne frequency meters. But I ran across an article by a guy named Lampkin, G.F. Lampkin, who had an article in a 1927, I think it was, QST, that where he referred to a heterodyne wavelength meter. And it was the same thing as a frequency meter.